Okay, I decided this would be easier if I wrote the problem completely out and just talked through this. And then I'm also going to upload a copy of these notes so that you could access them if you were actually when you're doing your homework problems. So this problem says in 1998, a San Diego reproductive clinic reported 42 live births to 157 women under the age of 38, but only 7 live births for 89 clients aged 38 and older. Is this strong evidence of a difference in the effectiveness of the clinic's methods for older women? Test an appropriate hypotheses and state your conclusion. So the first thing I wanted to do was define my population proportions. So I labeled P sub 1 as the proportion of women at the clinic under age 38 who have live births. And now this isn't my sample. This is the population proportion. So this would be, all the women who've ever gone to that clinic that's under the age of 38. And then P sub 2 is the proportion of women at the clinic, 38 and older, who have live births. So my null hypothesis is to say that there's no difference. So I have P sub 1 equals P sub 2. There is no difference in the proportion of live births between the two age groups. And my alternative hypothesis is a not equal to. It's a two-sided test. There is a difference. And the reason why I chose to do a two-sided test is because it says, is this strong evidence of a difference in the effectiveness of the clinic's methods for older women? So it's not giving you a direction when it just says of a difference. So you would want to make sure you did a two-sided test. So next thing up is to check our conditions. Well, it's not random, but it does seem reasonable to me that the women in the samples, we have 2 samples this time, are representative of all women who visit the clinic. So I don't have any reason to believe that 1998 was any different than any other year, so that seems reasonable. Because they seem like they should be representative of all the women, then the women should also be independent of each other. And this is key, both groups should be independent. So there would be no reason to believe otherwise, but that's really key. When you have 2 groups, they have to be independent, because remember, in this process we add the variances, and we can only do that if our 2 groups are independent. So that is key that you check that and mention that in your conditions. The next thing, I had a total of 246 women in my 2 groups together, and that's less than 10% of all the women who visit the clinic, not just in that year, but all the women who have visited. And then to check our NP, our large enough sample size, we have to make sure, or our success failure condition, we use the pooled p-hat value. So I add 42 plus 7, my 2 successes, I get 49 out of 246. So that represents the pooled value, because remember, we're assuming in our null hypotheses that there's no difference, that it just all comes from one big group. So that's what you use to check those conditions, and you'll see that I got 31, 126 for when I multiplied by n sub 1, and for my n sub 2 for the other group, the older group, I got 18 and 71, approximately. I rounded. So all the conditions are met. So now I name my test. I'm going to do a 2 proportion z-test for the difference of 2 proportions. Now I chose not to do the formula on this one, and you should be fine being able to when you just name the test. So I have my conditions met, name the test. Then I go to my calculator. So I set this up as a 2 proportion z-test, plugged in my information. Now notice my x1, my n sub 1, that represents the younger women, and then my other one's the older women. Notice I chose a 2-sided test, and then I ended up with a z-score, and I wrote that down. Be really careful with your p-value, and don't write down 3.65. This e to the negative with a negative 4 means it's 3.7 times 10 to the negative 4, so it's approximately 0.0004. Now, if you think the p-value is 3.7, think about that for a minute. This is a probability, and all probabilities are between 0 and 1. So you can't have a probability of 3.6. So you need to make sure that you look to the end of this and see that it's in scientific notation. So with that very low p-value, my conclusion, I said, was with a p-value as low as 0.0004, we have strong evidence of a difference in the effectiveness of the clinic's methods for older women. Now, when I wrote this, if you look back at the question, it said, is this strong evidence of a difference in the effectiveness of the clinic's methods for older women? And look at my conclusion. We have strong evidence of a difference in the effectiveness of the clinic's methods for older women. I used the same wording right from the question. Do that, because then you know you've answered the right question. So that works for your conclusion. Now, I didn't say what a p-value means. I wasn't asked to, so I didn't do that. Remember, a p-value would say, to interpret what a p-value means, if there was really no difference between the two groups, then the probability of getting results as extreme or more than ours is 0.0004. So that would be if you were trying to interpret a p-value. Okay, so then part B asks you, if you concluded there was a difference, which we did, estimate that difference with a confidence interval and interpret your interval in context. So most of the conditions have been met, but there's one condition that's different. When we do a confidence interval, we don't use the pooled p-hat value. So if you take a look at our success failures, we only had 7 live births out of the age 38 and older women. This needed to be 10, and it's not. So we do have a violation of one of those conditions. You'd want to make sure that you mention that. The rest of them are all fine. 42 was large enough, and there's more failures in both groups than 10. So the other conditions were met. So you would make note of that. Now you'd still go on with the problem, but you definitely want to acknowledge that that condition is not met. So that might mean when we get our results, we'd need to be a little wary of those. So we're going to do a 2 sample Z interval for the difference of proportions. So you want to make sure again that you name what the test or the interval that you're doing. So I went back to my calculator. The nice thing about this is it remembers what I had in there. I chose to do a 95% confidence interval. It didn't say I had to, but that seemed like a good one to me since it didn't tell me what to do otherwise. So when I did that, I get my confidence interval. I write that down. Now, a couple things I want you to notice is 0 is not captured in the interval. And that's important because if 0 was captured in the interval, if it went from a negative to a positive, then that would indicate that it's possible that there was no difference between the two proportions. Remember, this represents P1 minus P2. Whatever you put in first in your calculator, it's going to subtract it in that order. So this would be P1 minus P2. So this is the younger group minus the older group. So, and that makes a difference when you do your interpretation. So my conclusion, I said, was I am 95% confident that the proportion of younger women who have live births is between 0.09986 and 0.27787, higher than that of older women. So that's not saying that this is the proportion of live births. It's saying it's this much higher than that of older women. So again, this is a way that you can kind of link a confidence interval to a significance test, but I want to point out that the significance test we did was a 2-sided test. So then that can directly compare to a confidence interval. Remember, if it's a 1-sided test, then that's a little different. We have to be careful when we're interpreting that. So this kind of gives you an example, and this should be similar to number 16, I believe. So you can hopefully use this. And like I said, I'm going to upload the notes as well. So you can either print that off or at least take a look at that.